Okay, so first things first. What questions? Okay, here I want everybody with me here. Questions? Everybody got questions?
No questions.
On any of the unit 2 assignments?
I do.
Okay.
So I just would like you to demonstrate a problem where f of x is 4f of negative 7 or something multiplied.
Okay, so here let me pull up the assignment. Hey. Okay, here we go. Let's look at everybody kind of want you to go ahead and I'll leave it up to you. I just want you quiet, but if you feel like you got this and you don't want to watch this example, that's fine. You can work here for a few minutes. If you want to see something like this, pay attention. So this would be sort of a complex evaluation problem, right? We got a lot of stuff going on. We want to evaluate this expression, g of the quantity 4w minus 10 minus f of the quantity negative 5w plus 6. Okay? So what's that mean then? So here is g of x, right? Here is, we call that the function rule for function g. That's telling us what is g doing to the inputs. G is doing this to the inputs. Whatever we input, it is squaring and adding 4 to the result, right? So if I did g of a billion, I would just do 1 billion squared plus 4, right? If I did g of a, I would just do a squared plus 4. If I do g of the quantity 4w minus 10, then all I'm going to do is the quantity 4w minus 10 squared plus 4. Now that's a little bit complicated. You got to be careful with that, but we just have to simplify that algebraic expression. Right? Oh my gosh. Hello, Mr. Haygood. What's going on?
Yeah, I also know I'm just writing down
So let's look at this then. So what would that first part look like? If we take this bit right here, what's that going to be?
G.
Okay,
Well,
but
so parentheses.
so how do we say that? The quantity
Okay.
4w minus 10
No,
squared
plus 4.
plus 4. Okay, everybody got that?
Because the x.
We're filling in x.
Why?
What?
No, because
No.
So like g.
See, look what this is doing. The rule is g of x equals x squared plus 4. So now change x to say input. G of the input equals the input squared plus 4. So if the input is something complicated like this, it doesn't matter. Everything, the input is just behind my hand. We'll call it hand, right? So g of hand is going to be hand squared plus 4. Well, that's hand squared, right? I've got to square the entire input, even if it's a lot of stuff, right? That's what my rule is telling me to do. Whatever the input is, I square it and then add 4 to the result. Okay? So that's what we get from this first part. Then we've got minus, and here's my minus sign, all this stuff. Okay, so what's that going to work out to be? The rule for the function f is f of the input equals 8 times the input minus 8. Okay, so I'm subtracting all of that stuff. I'm subtracting the output of f when my input is negative 5w plus 6. Okay, so here's how I calculate my output. It's going to be 8 times x, but instead of an x, we're substituting that whole thing. Negative 5w plus 6 minus 8. But we got to be careful. I have to include that whole thing in grouping symbols, right? Because I'm subtracting the whole thing.
Could you just put prime the 2 and then subtract after?
You could, sure you could. But if I want to show this with algebraic steps, this is what it would look like, right? If I'm going to say this statement is equivalent to what? That expression is equivalent to that statement right there. Okay, and then what would we do? Well, we'd have to simplify this. Do you guys remember? You may not, and if you don't, that's okay. We're going to cover this stuff next unit. You could do this the long way now if you have to. but do you remember how to square out a binomial? Like if I have a plus b quantity squared, do you remember what the pattern for that is? You remember the a squared plus 2ab plus b squared stuff? I'm sure you did it, but it may have faded, and that's okay. So what you have to do for now then, because we'll cover those patterns soon, like within a month we'll cover those patterns. But for now, how would you do this then? How would you, the long way, how would you square out 4w minus 10? You would just FOIL it out, wouldn't you? 4w minus 10 times 4w minus 10. Distribute, add like terms. Sure, I'll do it. Yeah, I'll do it. Okay, so let's just take this step by step. There's a little review built in here, that's fine. So this part right here is just going to look like 4w minus 10 times 4w minus 10. And then let's kind of color code this whole thing. So this part is just my plus 4, right? And then we've got minus everything in the pink brackets. Well, this is easier here. All I've got to do here, this is just linear stuff. I'm just going to distribute the 8, right? So I'm going to get negative 40w plus 48 minus 8, right? Okay, so let's step down one more step. Now, here I gotta FOIL this whole thing out. So I'm going to distribute the 4w both terms. 4w times 4w is what? 16w squared. 4w times negative 10. Well, negative 40w. Negative 10 times 4w is another negative 40w. And negative 10 times negative 10. Okay, good. Plus 4. Now let's go ahead. Maybe we can combine a couple things here. What's 48 minus 8? 40. So that's the same thing as saying plus 40, right? And we'll go ahead and distribute the negative sign to both terms. So minus negative 40 is going to be plus 40w, right? Minus 40. And now we've got this broken down to just a string of terms, and we're just going to combine like terms, right? So let's do that. So we've got let's just highlight the like terms. We've only got one of those. How many w's do I have? I've got a w there, a w there, a w there, and then I need a new color here. What haven't I done? We'll do purple. And then I've got just constants I can add up, right? So I've got then, when all the dust settles here, I get a 16w squared. That's brown. So we got negative 40w minus 40w plus 40w just combines to a minus 40w. Everybody agree? Okay. And then we have a plus 100, plus 4 is 104, minus 40 is plus 64. That'd be my final answer. Okay, now, is there a way you could, now, I'm not going to give you maybe this resource on the test, so you got to be able to do this without it, but is there a tricky way I could use Desmos to check this? This gives you, and this is, I want you to get familiar with the technology. You want to see a tricky way to do? I think this will work. This is good practice. So if I pull up the Desmos, even just the Desmos Scientific, okay, so let's do a couple things. Let's define f of x. Okay. This is probably, maybe this is overkill, but we'll do this. If f of x is equal to 8x minus 8, and g of x is defined as x squared, whoops, forgot my equals, x squared plus 4. Now watch this. This is pretty cool. We could do this whole expression up here. I could do g of the quantity 4w minus 10 minus f of negative 5w plus 6. Okay, but look what it's going to tell me here. It's going to tell me try to finding w. Okay, so, oh, you know what? That's not going to work in here. Well, here's a way we could check it. I could pick a value of w. I could pick something like w equals 9. If I pick w equals 9, I get 1,000 for my result. How could I check just to see if I did it right? Go down and take my answer, right? 16w squared minus 40w plus 64. And what do you know? I get 1,000. Pretty good odds I did it right then. Does that make sense? Okay. All right. So there's a little to those. I mean, there's some algebra to do, but you get the concept. The big concept here is that we can evaluate functions at variable expressions, and that's something we do a lot later on in math. So this is really legitimate practice that moves you towards an eventual goal, an important goal. Okay. What else? Anything on the 2.2 assignments? Okay.
This is probably pretty easy. How do you take a definition that's multiplied by something? What are the steps? I'm not. So I have 4 f of negative 7 as f of x.
Mm-hmm.
So what are the steps to? Do you have to take away the 4? Or what do you do?
So I guess here, do you mean one like this? Let me just pull up a sample. What number is it on the assignment?
I think it's number 7 or something. 6? Yeah, it's 6.
Okay. Yeah, something like that.
Yeah.
Like that?
Yeah.
Okay, so what is this then? I'm not going to do the whole thing, but let's talk about how you would do it.
Yeah.
So if f of x is the rule, f of x equals negative x squared minus 3x plus 12. Do you see that when I'm doing something like this, here I'll take a picture so I can draw on it a little bit. Okay, so you guys see here that when I say something like f of negative 9, you get that that's just a number. That's just an output number. That's the output number I get when I input negative 9, right? So what's this going to end up being? This is all just going to equal 4 times that output number. You've got to find what that output number is. Plug negative 9 in for x and see what you get, and then multiply the whole thing by 4.
Why wouldn't you divide?
Well, why? Because I'm not trying to solve for anything. I'm trying to evaluate, right? I'm not isolating anything. I just want to know what is 4 times f of negative 9, right? The instructions here are evaluate the function or evaluate the expression or something like that.
So you would still input it as negative 9, not negative 28?
Where's negative 28 coming from?
Or negative 36, I mean.
Oh, no, right, because the 4 is being multiplied by whatever that number is. I can't distribute the 4, right?
Okay.
So everybody see here that, like, if you think you can distribute the 4, you're making the mistake of thinking that this is like f times times negative 9. It's not. This is this whole thing, f of negative 9. That's one thing, right? That's one number. F of negative 9 is what I get when I plug negative 9 in up here. We can figure out what it is. If I plug negative 9 in, I just get negative x squared minus 3 times x plus 12, where x is negative 9, right? So what's that work out to be? Negative 9 squared is what?
81.
81 times negative 1 is negative 81. Negative 3 times negative 9 is plus 27, plus 12. That just gives me some number. And whatever that number is, goes in there. Okay?
Yeah.
Okay. All right. So maybe I'm not going to do, where are you guys on the assignments? How many people are done with the 2.2?
I'm on the very last one.
I'm on the very last one.
Of 2.2?
Yeah.
I'm on the
Okay.
second one.
Second one. Okay. Okay. So I mean, I'm not going to try to overload you. I'm going to make a small step forward today. Yeah, question. Oh, you got a question on one?
I just did the one that Aaron asked about,
Uh-huh.
like I did with.
Okay, so there's a little mistake in this thing. Okay. Do you have your work down?
Yeah.
Let me, so stop me with 10 minutes to go today, so people they can get some individual questions answered, and we'll get through this. Yeah, same thing. Okay. Okay, so it makes, who's responsible for that? Somebody be the timekeeper, stop me with 10 minutes to go. No matter where we are, I'm just gonna stop, so you guys can come up and get some questions answered. Okay, so for today, I want to show you, just extend this just a little bit today. So we want to write linear equations using the point slope formula. Okay, so this is probably new to you. I don't think you've probably seen this stuff before, I would guess. Okay, so the way this works here, this is just the third form of a linear equation, and this is a form that, at this level, we'd never probably leave a function in this form. Like when we get to calculus, in my AP calculus class, we're doing stuff right now like where we're finding tangent lines to, and for those guys, they've done enough algebra at that point in their careers that if they plug in the numbers and write it in point slope form, I call it good. I know they can do the linear algebra to solve for y, but I'm not going to make them do it. Right? It's still the same line. At this level, we still got to take it to the finish line and put it in slope-intercept form. Okay. Here is slope-intercept form. If I want to write a linear equation and I'm given the slope or can calculate the slope of the line, and I know a point that it passes through, we're going to call the coordinates. Let me everybody click them all the way close. I want to get your undivided attention on this stuff. And I'll let you, maybe I'll give you 15 minutes at the end instead of 10. How's that? We're going to write the coordinates of the point that the line passes through as x sub 1, y sub 1. In math, we just say x1, y1. Okay? When we attach the 1s to that, what does it do? Well, actually, it makes it no longer a variable. It makes it a specific value of x and a specific value of y that represents a point on the function, right? So it's not just a variable x and a variable y. They actually represent some place on the function there, okay? We're going to plug in numbers for x1 and y1. Those are going to be the ordered pair that represents a point that the line passes through. Point slope form is just this. Point slope form is just y minus y1 equals m times the quantity x minus x1. Now let me show you why that makes total sense. Okay, if I take that form, y minus y1 equals m times x minus x1. If I solve for m, what's the only thing I have to do to solve for m? Is that the right? I don't know. Oh, right there. They're right there. Yeah, those two. What's the only thing I have to do to isolate the m on the right side?
Divide by parentheses, right?
Divide by the quantity x minus x1. Agreed? So I would end up, if I did that, I'm going to get m equals y minus y1 over x minus x1. Well, doesn't that make sense? Right? If I've got my line, here's the xy plane, and I've got my line. I've got my line, and let's say here's a point with specific coordinates x1, y1,
Is this
and
like
I'm,
the y2?
say it again.
Is this like the y2 minus y1?
It is, right. So I'm going to take any other point on the line. This is a specific point that's pinned down. Like those are coordinates we know. But any other point on the line is going to be represented by just a value of x and a value of y that can vary, right? Everybody agree? I mean, it could be, like here it's gonna be one value, but I could drag this bead along the line and I could create different values for x and y. And so they're variable, but they're tied together by the equation that determines the line, right? Okay. Well, if I make a little slope triangle here, you probably already see this coming. If I make a slope triangle, I put this on the wrong side. It's interfering with my slope triangle.
Oh, I see what you're saying.
If I create a slope triangle out of this then, well, slope is just rise over run, isn't it? So that tells us that the slope is just gonna be this distance divided by that distance. But what if I flip these points around? That would be a little more convenient. And it really doesn't matter, but just for the sake of making this process a little bit easier, let's say that this is the fixed point x1, y1, and this is the variable point xy. Well, then what's my slope going to be? The rise is just going to be this y value minus that y value, isn't it? So that's going to give us, this distance right here is just y minus y1. This distance right here is just going to be x minus x1. Everybody agree? Yeah. That x value minus that x value. And so that looks an awful lot like slope, doesn't it? So point slope, it's consistent with just the definition of slope, right? Question?
So those two, like, equations are the same thing, so y minus y1 equals m.
Right, they are.
So they
So,
are the same
So we
thing.
could use that as
So you.
well, okay, but no, this is the point slope form. So all we've done is I just want to justify why that form makes sense, is all I'm showing you. Is that this is really just kind of a re-expression of the slope formula, right? But we want to think of it in this form because this is a real convenient way to do it. Now, you'll see why. You'll see why. When we do some examples here, like if I want to find the equation of the line that has a slope of -4 and that passes through the point -1, 7, well, then those are just the values I'm plugging into the point slope form, right? The value of m I'm plugging in is -4. The x sub 1, or x1, there's the x coordinate, is going to go there, x minus -1. Y sub 1 goes right there, and now all I have to do is simplify, right? I get y minus 7 equals -4 times x plus 1, and look how easy it is to solve for y. I just distribute the slope and add the 7 and collect like terms and drop the pen, I'm done, right? Very simple. Okay? You see what I'm saying? So let's try this one then. If I want to write the equation of the line that passes through the point -6, -5 with a slope of 2/3, we start off with just slope-intercept form. And why do we start off with slope-intercept form? Because I'm given a slope, not slope-intercept. What do we call this? Point slope. Point slope form. And why do we start off with point slope form? Because that's what we know. We're given a slope and a point. Okay? So we end up with y minus what?
Plus
-5, good.
Or just put plus one.
We could, yeah. Equals m, which is what?
2/3.
Good. Times x minus
Or plus.
minus -6, exactly. And so if we simplify that, we're just going to get y plus 5 equals 2/3 times the quantity x plus 6. So what are my two steps to solve for y? Distribute and subtract 5 from both sides, right? So we get y plus 5 equals 2/3 x plus 4. Subtract 5 from both sides, and I get y equals 2/3 x,
Minus 1.
right?
subtracted by, okay.
Okay, no big deal.
That would just be.
And that's our final answer?
That's your final answer. That's it, right? And that's in slope-intercept form, which is our preferred form, right? So remember, to put it in slope-intercept form, all you do is simplify. That's it. You just isolate y and simplify, and it automatically ends up in slope-intercept form. Okay, so then, now these aren't on, this is kind of above and beyond just the little worksheet things. I got some problems I made on Moodle here that are a little tougher. Oh, actually, hang on, we got this one first. So see if this makes sense. Now, how do we go a step further with this if we're not given directly, like these last ones were pretty easy. They gave us a slope and a point. We just plug and chuck, right? Plug that stuff into the point slope form and we're done. How do we deal with a situation like this where we're not given 2 points exactly, we're given, we're not given a point in the slope, we're given 2 points instead. What's the only extra step? Calculate a slope, right?
Yeah.
So all we have to do here is we're just gonna, to turn this into a problem like we just did, is we have to calculate the slope from the 2 points. And then we use, doesn't matter which point we use for our point?
No,
No, they're both on the line, pick the easiest one. If one of them is clearly easier to plug into the equation, use that one, right? So for example here, so I guess if we wanted to summarize this in notes, we're just gonna use the slope formula. M equals y2, right, you guys know this one, y2 minus y1 over x2 minus x1. And then we just plug into the point slope form.
Oh, so we're transforming that into point slope form, that's what you're wanting us to learn?
Yeah, exactly. So then it makes sense, like for this example here, right, we calculate a slope. Now, when you're calculating slope, let's talk about this for just a second, because sometimes people make a mistake with this. Does it matter which x value I subtract from which x value? No, but I have to be consistent.
Yeah.
So if I'm subtracting the first x value from the second, then I also have to subtract the first y value from the second. I can't mix and match, obviously. So in this case, we're doing second minus first. So we got y2 minus y1, 8 minus negative 2 is 10. I have to do x2 minus x1 then, right? So negative 6 minus negative 2 is negative 6 plus 2 is negative 4. Positive over negative is negative, and 10/4 reduces to 5/2. Yes, Jim, question?
You just told us at 2.
Oh, okay, so we're at 2:15?
2:10.
Oh, I gotta stop it. But you guys see where we're going with this?
Yeah.
Okay, so then all we would do is we would pick the easiest point, which would be, for example, in this case, we just pick this one. And we do what we did in the last example, we use point slope, okay? I'll call her quits there, we'll pick this up on Monday. Okay, if you've got questions, bring them up.